every society has a person who we can call a troll. A joker who likes to highlight every mistake and always has a different point of view than others. Thanks to him, we always need to remember about putting our laptops into the sleeping mode to avoid strange wallpapers with naked David Hasselhoff or something like that. But without him, our life will be much more boring. Please welcome Michał Buczko.
Hello everyone. Does anybody hear me well enough that I cannot have to use the microphone?
All good, I think.
Okay. So let me start with a few questions to you. How many of you are actual testers? Nice. How many of you work in agile environment? Nice. How many of you are doing exploratory testing? Okay. How many of you are starting to design the exploratory sessions when you already have a working software with implemented functionality?
Too long question.
Okay. So basically, the thing is that I will try to describe you my approach to exploratory testing. So it's the way that we are doing the exploratory testing in New Voice Media, at least in my team. And to start with, so who am I? So I'm security tester in PCI applications in New Voice Media. So we are working on the card payments software. I've been working in New Voice Media for the last 2.5 years. I've been working as a software tester for the last 8 years, usually as a software testing consultant in different companies. What I want to present to you now is our approach to exploratory testing, how we are doing this, why is it, at least for me, a good way of running exploratory testing, hopefully for you also. I want to show you how different it is from a scripted testing, so the testing in which you define the whole testing scenario in advance before seeing actually working software, already implemented functionality. Why I think it's good for you to learn it is because it's very new in Poland to use exploratory testing. I was working at most at 3 projects where we are literally doing exploratory testing, not like naming it, let's do exploratory session, but running strict functional testing. But we really were getting a software that works and we're starting from the scratch how to test it and learning how to do it. And how I want to convince you to do it is I will give you a few examples. I will give you an example process, how you can run exploratory sessions in your project. I will give you probably some of materials where to start learning or extend your knowledge. And probably, if we have the time, I will give you a cheat sheet with possible scenarios. My goal is to convince you to do as much exploratory testing as you can and as less scripted testing as possible. Probably to convince your project managers to move those scripted scenarios to developers, to extend the trust so that you from start will assume that developers are bringing you the software that works, and you only want to try out a different approach and a different scenarios to test it, not just assuming there are lots of bugs. Let's go a simple happy path scenario so that at least 10 bugs will be found. So what it is to do exploratory testing. For me personally, it's like a situational practice. So you get the software which is already implemented, you got a demo from a developer, and then you get a time, like a few hours, maybe a few days, in which you are running exploratory sessions to try out how does it work in a scenarios which are not defined as a part of definition of done, which are not defined by the product owners, because basically the assumption should be that tester should run more complex scenarios than just repeat something that can be tested on unit test level or integration level on any other different scripted level. So if there's a scenario that is testing something through spec flow, behavior tests, or integration tests, or unit tests, you should just double check it, but not waste too much time on checking every possible scenario from that point of view, because it should be tested by developers. You should be focused on learning, test design, and test execution. And basically, to do it in parallel, you need to have the approach in which you learn about working functionality before designing the test. If you have like a description in Jira and you are defining all the test results and all the outcomes that should be given, then this is something that I would call a scripted testing, because you are already producing a script in which you are defining the results. You are not running like exploratory session or scenario in which you don't know how the system would behave. The change in it is that at the end, after the test execution, if you will have the results, you just speak with the developer or the product owner and you define or decide if it's a bug or if it's a feature. Because sometimes you find a strange behavior of the system, but the product owner has no knowledge about it and he has no idea at first if he wants to define it as a feature or a bug. Sometimes you find like you have all the definitions if you put numbers in some fields, but if you put the letters and you get an exception or error message, sometimes it's not a bug. Sometimes it's just how it works and it should work like this. And sometimes the product owner will tell to you, let's leave it like it is. So basically, if you are doing these three things in parallel, and you are doing it not based on Jira ticket or a specification, but based on a working software that you get from your developer that is already unit tested and integration tested, then you are doing the exploratory testing. Because then you got a final product that possibly can go to the production, and you are just trying to learn how it works and check what are the results. So for me, the best metaphor is to compare exploratory testing to puzzles. So when you are just making a puzzle and you find a new piece that fits, then it's changed the whole environment. So now when you are searching for the next one to put in, you are searching for a different one. So every scenario during exploratory testing that you run is affecting what will be, for example, the next step. Usually when we are running exploratory sessions in our product, I've got defined like only 3 first steps of a scenario, and based on the results that I get through the scenario, then I'm defining what would be the next step that I will take, or what will be the scenario that I will continue with. So based to the comparison, exploratory versus scripted. So scripted testing for me is testing in a way that I've been doing like 3-4 years ago. So basically I get a specification, and then I got like a huge tool, for example, Quality Center or something like this, and I'm asked to print out all the test scenarios that I want to run against that software, even before the developer is even starting implementing it. So I get a specification, like a ton of paper, I read through it, I design all the test scenarios, I specify all the operations that I will do, all the expected result that I will get. So I define what, after each step, what is expected outcome, what comparisons I will make, so what should change in the UI, the colors, the images, or whatever it will be. And then I define all the controlling mechanisms. So no matter if it's manual or automated testing, everything is defined. And then developer, based on a process that the company is using, is starting the implementation knowing which scenarios will be run, and then he can prepare for it. Or he doesn't know it, but basically when I get working software, I've got everything already defined. And usually then there is a project manager who is saying, you have like 20 scenarios or 100 scenarios. Let's assume it's 10 minutes per scenario. It should be 3 days to test everything. And you are not allowed to modify any of those tests. So usually you end up with tons of bugs, because if everything gets broken in the middle, Sometimes, because the test case is already frozen, you just raise a bug. Because if you get a bug, then you can modify the test case as a part of retesting the bug fixing, for example. And that's awful way of running tests. That makes software being released every 20 months, 15 months. That was the cycle time that we were having in such companies. And when you have exploratory testing, you start with learning. So basically, you have the meetings with product owner when you define what will be implemented. Then you have developer who is implementing it. We are using something that we call dev test pairing. So I'm sitting next to the developer in a similar way as you can do it in pair programming. But the thing is that I'm seeing the working software on his or her development environment. I can define him some scenarios that he should add to the unit test or integration test, or I can ask him to run some sort of functional test on his environment. Then we have the part of the test design. So test design is, for example, first step is when I'm doing the unit test review. So the developer is showing me all of the scope of the unit testing that he's put on the software that he has implemented, and he has asked me if I want to change any of the unit tests, if I want to change any of the test data, or do I want to extend it with different scenarios. So basically, when I will be running my exploratory sessions, I will know whole scope that is already tested, that I don't have to check second time. Because I have the trust that he showed me that the software is working on his environment while I was learning it, and then he proved me that he has tested it during the unit test phase or integration test phase. So the last step is the test execution. So basically, when we are doing it on the dev environment level, the test execution is called on our team feature demo. So this is the moment when I'm sitting next to the developer and he's showing me finished implementation with actually working software. And we are interpreting the results because he asked me what steps I want him to proceed on his dev environment. And basically, when this is all finished, then he's moving the software to the test environment, and I'm starting the loop from the beginning. So I'm trying to open that functionality on the test environment. Then the developer sits next to me and I can ask him how to configure it, how to make it work. Then I'm starting from the scratch the test design, because now I'm test designing my exploratory session on my test environment. And then I'm running the test execution. If there are any strange things, then during the test results interpretation, I just ask the developer to sit next to me, and I'm showing him the results. And usually, it's the developer who decides if it's a bug or not. If he says it's a bug, then we raise a Jira ticket. If he says it's not a bug, then usually we go to the product owner and ask him that he confirms it's not a bug. And we never had a situation when the developer said it's not a bug, and then the product owner said, no, I think it is. Usually, it's always the way that if developer says it's a bug, then when we have, I don't know, stand up or whatever, and we tell the product owner that we have a new Jira ticket because we found this thing or something else, he agrees with us, and we are fixing it. And if we say to him that we found something new, but we decided this is not a bug, he always agrees with us. So we have very technical product owner, and we trust, as well as I trust my developers, the product owner trusts us and we trust him. So usually we don't disagree on the level if it is a bug or it's not a bug. So that is how I remember scripted testing. So I had a project where we had a test plan which was defined 12 years before I was running the test. It was like 300 document, and it has all the defined steps, expected results, and I had only a room to place pass or fail. And I was asked to repeat that test. Basically, it was part of the regression, it was run every 3 months, and it took a month to run it. But the thing was that the person who has defined the whole scope was not working on a company since, I don't know, for last 8 years. So nobody could even update this list because nobody was familiar with it. But the company found a way that this checklist should be so generic that even a new person who sees the software for the first time should be able to repeat it. The only thing is that when they had like a step saying click on a control button, he just need to go to the developer and ask him where is the control button. But he was not allowed to add a note where that button is, because maybe in the next 3 months this button will be somewhere else. But there will be always a developer who will know where is the control button. And usually the assumption was that bugs are everywhere. Because when I was running through that scope, I had an idea that every second step, I have no idea what I should click. And the first thing that I was thinking of was, it doesn't exist anymore, somebody took it out, it's a bug. And I was writing hundreds of bugs. And they were all rejected because I was not familiar with the software, because the checklist was too generic and I was not able to run it in a smoothly way. At the beginning of running those regressions, my idea was to fix the scope, to fix that document, but after running it 3 times, I just resigned from being a part of that project. Because I said, no, it's too huge. I will never have time to update it, or remove it, or convince anyone to do it. When you are doing the exploration approach, you are doing not checking, you are doing the testing. So you are not having like a scenarios in which you decide what will be the result. You are not a part of, how to call it, like an old-fashioned team, when there's a test designer who is writing down all the scenarios, and then there's like a bunch of testers which are just running those tests which are already defined by somebody who are more experienced and is more familiar with the application. You are some sort of a detective, because if the developer was checking all the scenarios that are defined in the definition of done, then all scenarios that are left are the scenarios which are not defined, and there's no definition of what should be the result. And then you just, it's usually some sort of searching for the edge cases, but sometimes the edge case can be very important for the business, and sometimes you are really defining a way that the application works, and then you just extend, for example, instructions or documentation that you are giving to the customer, saying, if we have this field and there are only numbers allowed, but if you put their letters, the behavior will be like this. And then it's not so troubled to configure it for the customer, because he is familiar with that if he puts the wrong chars or wrong letters, then this will be the result that he's getting, and he will not start raising the cases against support or whoever it is, because I put there some strange value and I got this strange error message. It is expected error message because it should be this way. So why do we need exploratory testing? What is the benefit from running it? So the bad news is there are no research comparing exploratory testing against functional or scripted testing. So there's no numbers saying it's better to do it exploratory way because you are more efficient, the bug rate is less, or you have less issues on the production or whatever it is. So nobody is comparing one against another because it's a totally different thing. But there is like, how to call it, like industrial feeling that exploratory testing is more efficient. Because when you don't have defined specification, you don't have defined outcomes, you just get the software and you have to run user acceptance testing or whatever it is. When you run it through exploratory sessions, the first bug will be a lot faster if you don't start with reading the specification, creating a test plan, creating a test procedure, defining all the test scenarios, and then running the first test scenario. So it will be faster when you try to find the bug, but the thing is that it won't be faster to, for example, isolate the bug and define that bug in very clear way what is the reason for that bug. So when the developer will, for example, try to investigate it or debug it, it will be the same amount of time, no matter if you found that bug through the scripted testing or the exploratory testing. Usually the time that it will be using is the same. How to start it? Usually you need to follow your instincts. You should treat it like if you are walking through a forest and then the application jumps out from behind a tree and asks you to test it. You cannot assume that you will get all the specifications and you get all the results defined and everything else. You just sit next to the computer and you try to click it and just let's see how it behaves. So one of the strangest bugs that usually I'm starting with when I've got exploratory sessions in new projects or new companies is that I'm starting the applications and I'm going on a lunch break for an hour, and then I come back and then just try to click on anything, and if I get an exception, then I wrote down a Jira ticket that if I log into the application, then went on a lunch. After 1 hour, I click on it and then there's an exception. And usually there's no definition in specifications that says that the session timeouts in this amount of time or other amount of time. Usually when it's, for example, web application, it's reusing some default value and it's never in the documentation. So basically when you try to run those sessions, you don't have to use influence from the product owner or developer how to test that software. You just sit next to it and you click on it. And usually the first few sessions that I'm running against a new feature, I even ask a developer to not bear with me for that time, because he will try to suggest me to try a different way to run the same scenario. How to do it in an agile sub-process. So basically, on our companies, projects, we extend those 3 steps from learning, designing, and execution to 6 of them. So we have learning, design, mechanics, execution, observation, and then interpreting the results. So starting with the learning, we try to learn how the software behaves. We start with the simple scenarios. So we just try to do the happy path scenarios. During these sessions, we found a different options that we can use, or different things. So we call it nouns and verbs. Basically, nouns are the objects on which you can interact on. The verbs are the operations that you can run through the scenario or through the system. And then you find the alternate paths. So basically, most of the systems allow you to do the same thing in 3-4 different ways. So then you have additional exploratory scenarios that you find to repeat the same outcome, but using a different way. So you can use a keyboard shortcut. Instead of clicking on a save button, you can use save button or save option from like a file menu or different things. You can write down the context diagrams. So then you will see how you extend your knowledge and your scope from a simple happy path scenario to different additional negative scenarios, different paths, different options. And then you can use the variables. So the variables are the things that you can change during a scenario. So if you're saving a file, you can have a correct file name or a not allowed file name or whatever it is. So then you can just modify it. And that brings you the whole scope of the exploratory tests that you will run against that feature. Then you are doing the design. So usually that sort of mind map or scope is a starting point of the design. So from the dictionary, the design is a way to define something that you have in your head. How do you want to proceed with that? But you need to remember that designing is not a scripting. So design, it's not a plan. It's just how you want to proceed with that plan. But this design should be reusable. So, for example, in our team, we are not using test data inside the mind maps or the test scenario design. We are just based on the operations that we do. To do it this way, it allows anybody else to run the same scenario, but use the data of their own, not to have influence of reading the data that we use and try something similar. So we are not saying that we put here numbers or letters or whatever in that field. Just try it out. There are some heuristics that can be used. So for example, you can use the file system interactions, like create, read, update, delete operations. You can, if there's like copying or modifying fields, you can try to do it on none of the fields or files or one files or many files. And there are many, many more. So you can do it based on the timing. You can have scheduled tasks or immediate tasks or whatever it is. And then you go to the mechanics. So in our company, we are using charters. So for example, the definition of the charter, how we are defining a test scope is to explore an area with some sort of resources, constraints, tools, operations, external systems, internal system, whatever it is, to discover some sort of information or some sort of behavior. And usually, we are time boxing those sessions, so usually it's 2 or 3 hours. If you need more testing, then you are just creating another charter. And you spend another 2 or 3 hours on that other charter instead of extending that single one to like a huge level. So when you have, during that time when you're exploring and identifying states of the information of the system, you can then divide those charters based on those states, for example. Not to have everything in one place. And then in the charter you can run like the resources or constraints can be the events that can trigger the state changes. So that will, at the end, change the behavior or the result of the system. And then you have the executing and observation. So exploratory testing doesn't have to be always manual. If you have already designed a charter and you know what kind of scenarios you are running, and if that charter will be repeated many times, you can even automate the execution. So sometimes when you are running a charter through a system, you are always logging in, and you are always logging in at the same, for example, user. And then you can have like a single script that will log you in, and then the exploratory part starts when you're already logged in a system. You don't always have to run it straight manually, because sometimes, for example, you need the test data and you are uploading it to the database, and it's easier to have a SQL script instead of clicking through some sort of SQL tool and put by your hand every test data that you need for your testing. Then, during this phase, you are doing the testing and collecting the results. Based on the results, you can have like a note-taking technique, whatever you use. We usually use mind maps. There was a slide, a short one about this mind maps, but usually we are running mind maps, or we use Evernote to make like a huge documents or small documents of our observations. Then when you have the results, you can divide them, and if it's needed, you can create a new charter. So you can again extend the scope and go back to the learning, design, and execution steps. This is an example of mind map. So mind map is a way to describe information in a creative, simple way. It's easy to be read by no matter if it's a technical person or product owner or business person. And you can add here colors, attachments, images, whatever you need. So it's a really easy and funny way of collecting the results and collecting the data. These are examples of mind maps. So we can have project status in a way of mind map. You can have a project plan.